Imagine you have a twin. Same birthday, same age, down to the minute. Now imagine one of you gets on a spaceship, flies out into deep space at nearly the speed of light, turns around and comes back. When that spaceship lands, the twin who stayed on Earth has aged 20 years. The twin who was traveling has aged 6 months. They're still twins, but one of them is now genuinely physically younger than the other. This isn't science fiction. This isn't a thought experiment that stays theoretical. This is a real, measured consequence of physics. And the strangest part is that it's already been tested on Earth with actual clocks. So let's start with the obvious question. How can identical twins end up different ages just because one of them moved? The answer starts with something Einstein figured out in 1905. Time isn't fixed. It doesn't tick at the same rate for everyone, everywhere. The faster you move through space, the slower you move through time, relative to someone who stayed still. This is called time dilation, and unlike the mountain effect we talked about before, which comes from gravity, this version comes purely from speed. The closer you get to the speed of light, the more dramatic the slowdown becomes. At normal speeds, like a car or even a jet, the effect is so small it's meaningless. But push close enough to light speed, and the effect stops being a rounding error and starts being enormous. At 99.5% the speed of light, time for the traveler slows down by a factor of about 10. At 99.99%, that factor jumps to over 70, which means a 6-month round trip for the traveling twin could line up with 20, 30, even 50 years passing back on Earth, depending on exactly how fast the ship goes. Here's where people usually get stuck, and it's a fair question. If motion is relative, why isn't this symmetrical? From the traveling twin's point of view, isn't Earth the thing that's moving away from them? Shouldn't they both age slower from each other's perspective, canceling out? This is exactly why it's called a paradox, and the resolution is the most interesting part of the whole thing. The two twins are not actually in equivalent situations. The Earthbound twin stays in one steady, unchanging frame of reference the entire time. The traveling twin does not. To leave, turn around, and come back, they have to accelerate, decelerate, and accelerate again. That change in motion is not relative. It's real, physical, measurable acceleration that only one twin experiences. That break in symmetry is what settles the paradox. The traveling twins' changing velocity is what makes their aging genuinely different, not just a matter of perspective. When they reunite, there's no ambiguity about who aged less. It's the one who accelerated. And here's the part that makes this stop sounding like a thought experiment. We've actually confirmed this with real clocks, without needing a spaceship at all. In 1971, physicists Hafele and Keating put atomic clocks on commercial airplanes and flew them around the world, then compared them to atomic clocks that stayed on the ground. The airborne clocks came back measurably out of sync with the stationary ones. Off by nanoseconds, but exactly the amount Einstein's math predicted. It gets even more practical than that. GPS satellites orbit the Earth at high speed, and their onboard clocks experience real-time dilation because of it. If engineers didn't correct for this effect every single day, GPS positioning would drift by miles within hours. The phone in your pocket is quietly relying on relativity being true every time you use a map. So here's what that actually means, if you sit with it. Time isn't a shared universal clock ticking the same way for everyone. It's something that depends on how you're moving through the universe. Two people can start out exactly the same age, take different paths through space, and end up genuinely different ages when they meet again. Not because of illness, not because of biology, but because of velocity. Which means somewhere, in principle, there could be a version of you who left Earth fast enough, for long enough, to come back younger than your own little brother or sister. Not older, younger. If you want more videos like this, don't forget to subscribe.